Hi everyone, it's Mrs. Sommer here to talk about converting between moles and particles, or moles to particles. In this lesson, students will be able to convert moles of a substance to particles of that same substance using Avogadro's number. So, scientific notation. The exponent in scientific notation is equal to the number of times the decimal point must be moved so that the number in front of decimal is between 1 and 9. So we don't have, if there's not 10 or 11 times 10 to the 12th, it's going to be 1.1 times 10 to the 13th. So a negative exponent to get a standard number will be less than 1. So 9.715 times 10 to the negative 5th. So we take this decimal, we're going to move it 1, 2, 3, 4, 5, and then we put zeros in here as our answer. A positive exponent means we're moving the number, it's bigger than 1. So 5.6 times 10 to the 4th is, we have 5.6, and then we go 1, 2, 3, 4. We put zeros in those blank spots, and we get 56,000. We use scientific notation because the mass of a carbon atoms in 1 carat diamond, if there are 10 with a lot of big number of carbon atoms, and each has a mass of very, very tiny, versus calculate the mass of carbon atoms in a 1 carat diamond if there's 1.03 times 10 to the 22nd carbon atoms, and each has a mass of 2.0 times 10 to the negative 23 grams. It's a lot easier to even say those numbers than it is to say those bigger numbers. So let's practice scientific notation. So write in standard form. Okay? So in standard form for this one, we have 4 times 10 to the 5th, which is going to be 4, and then presume that there's a decimal there, so 4, and then we're going to go 1, 2, 3, 4, 5. So then we're left with 4, 0, 0, 0, 0, 1, 2, 0. So 400,000. The next question is 7.25 times 10 to the 4th. So if we start 7.25, then 1, 2, 3, 4, we have 72500. So 72,500. So you try number, this last one, the blue one. What is 3.24 times, 3.2456 times 10 to the negative 8th in standard form? So if we write that, we have, so I'm going to write it over here, 3.2456. Now I'm going to go the other way, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Okay, and then we have here. So our number is 0.000000. I believe there are 7 zeros. 1, 2, 3, 4, 5, 6. So 7, 3, 2, 4, 5, 6. And yes, putting a 0 here in front is required. Because the reason why that we put a 0 as a placeholder is because that number, if whatever we are measuring or doing has the potential to be bigger than 1, then that 0 is a placeholder. So in everything you do in this class, you need to put the 0.00 and not just leave that leading 0 off. Otherwise, you'll be marked wrong on your problems. So these ones, now we need to write these numbers in scientific notation. And to do so 45,000, so my imaginary decimal is here. 1, 2, 3, 4, so 4.5 times 10, and I moved it to go from standard to scientific. It's a bigger number, so it's going to be a positive exponent. I moved it 1, 2, 3, 4, so 10 to the 4th. For the next one, I have this 9 million, and so I'm going to go 1, 2, 3, 4, 5, 6. So 9.0 times 10 to the 6th. Now you try the next one, the one in yellow. So in this one, it's a smaller number, so our exponent will be negative, but we went 1, 2, 3, 4. So 3.78 times 10 to the negative 4th. So using your calculator with scientific notation. So here's the TI-84 plus C plus Silver Edition. You guys should all have the app installed on your computer from math class on your Chromebook. So this E here is this answer E to the 23rd. It means 5.6 times 10 to the 23rd. It's the same as this, but when you get an answer, so a calculator, if you plug it in this and you're doing some multiplication or division and you get this as your answer, you cannot write this as your answer on documents in this class. It's just how the calculator gives that notation. So you're going to write times 10 to whatever. So that E means times 10, and then the 23rd is, so this would be written as times 10 to the 23rd. So when multiplying or dividing using scientific notation, make sure you put your questions in parentheses. Okay, your answers in parentheses. And double check that your answer, if you have scientific notation in your answer. A lot of students will just write 1.56 as their answer, which would be marked incorrect because it's not correct, because the answer is actually 1.56 times 10 to the negative 16th. And then to put into scientific notation, you need to use the E. You'll hit the second button and then the comma. So second comma to get that EE as your answer to write it in. So you would hit, to put 5.6 in, you would write 5.6, second comma, and then 23 would be how you would enter this into your calculator. So remember, a mole is a counting unit in chemistry. So remember, 6.02 times 10 to the 23rd is Avogadro's number, which is a mole of anything. So since Avogadro's number is equal to 1 mole, it will be the conversion factor between moles and particles. So 6.02 times 10 to the 23rd particles over 1 mole, or 1 mole over 6.02 times 10 to the 23rd particles. So converting from moles to particles. So how many molecules are in 6.25 moles of titanium oxide? So here, if you look at it, the difference between the lessons on converting from grams to moles and moles to grams is you first had to calculate the molar mass. Here, going from moles to particles or particles to moles, you don't need the molar mass. So we're going to start off with, we're given 6.25 moles TiO2. And so we're going to have our 1 mole of Ti from our O2 from our conversion factor on the bottom. And then we're going to use Avogadro's number times 10 to the 23rd molecules TiO2. And then we're going to answer that in our calculator. When we do 6.25 times 6.02 times 10 to the 23rd, we get 3.76 times 10 to the 24th molecules of TiO2. Okay, you try. How many ions are in 75 moles of S2 minus? So when I do the calculations, I get 75 times 6.02 times 10 to the 23rd ions, S2 minus, is equal to 1.25 times 10 to the negative 22nd ions S2 minus.